Welcome everyone. My name is Brandon Henrique, and I'll be giving this short kind of research presentation on lessons learned 1 year of teaching SNAP to college students, high school students, and K-12 teachers. I had this really awesome opportunity this past kind of year to teach all these different populations. And I'm going to kind of start with just like what was the road that led me there to be able to do this in the first place. So a little bit about me. I'm currently a PhD student at Berkeley School of Education, where I study kind of the future of critical CS education. So my work largely focuses on bringing justice to computer science education and how do you incorporate culturally relevant pedagogy to the classroom. Before that, I was a TA for the BJC college course at Berkeley. So I TA'd for Dan's CS10 course for about 4 or 5 semesters, I believe. I currently work I work for SAP on the SNAP development team. And before coming back to Cal for my PhD, I got my master's in urban education while I was a 7th and 8th grade science teacher in Richmond, California. So you can kind of see my interests were aligned with like teacher education. I worked with college kids. I taught in middle school. Now I'm working with the SNAP team globally with curriculums around the world. And then I also went to school to especially get a master's of kind of teaching in schools. So with that kind of all together, I've been able to teach a lot of students in my first year as a PhD student through BJC and through SNAP. And I want to kind of offer this presentation as a way to things I learned along the way and any differences that were kind of, prominent as I kind of went through this. So what were these 3 learning populations and 3 learning opportunities? So the first one was a high school student, not first one, rather. The middle one I'll talk about is the high school student summer camp. And each of these I'll kind of describe later in the presentation, but I want to kind of overview. It was a high school student summer camp. The other students we're going to talk about college students that are in like an introductory computer science course for non-majors. And then the one that I'm really excited to talk about was I just finished teaching a pre-service teacher block-based programming course where they were learning computer science. And then I'll end today's talk with a little bit of kind of overall findings and recommendations I had for kind of instructors, depending on the population, and then some connections to computer science education research and where I think there might be some under-researched fields based off kind of the review of the literature. So I'm going to start with the college students. I've done this the most. I've taught CS10 4 semesters, whether it was a lab, discussion, a little bit of everything. And this is going to serve for this talk as kind of like the baseline group. And my logic for that is high school students are a little younger, and then the teachers are definitely a lot older. So it's kind of like they get to kind of split the middle, and we'll use it as kind of the reference group. Now, in my most recent semester of teaching CS10, we had over 350 students in the fall, and almost every student in the course has not coded before. And it's kind of framed as the intro to computer science for non-majors, but many of our students do find a love for computer science in the course and end up majoring in it. And we know this for a couple of reasons, just like with exit surveys. But Dan shared a great story yesterday where the first day of class, the instructor kind of says, "Oh my gosh, who's coded Python before? Raise your hand. Who knows Java? Raise your hand." And then everyone's like, "Oh yeah, I know everything." And then it's kind of like those people, you should probably move on to the next course. Like this is meant to be kind of the open floor. We're starting from nothing. Let's all grow together in computer science. And with that in mind, I also had the unique opportunity that I taught this while I was an undergrad at Berkeley in 2018 and 19, left for 2 or 3 years and came back. So I noticed a lot of major differences pre and post pandemic as an instructor that I didn't really expect. A lot of my students in the fall when I came back to Cal had just gone through 2 years, half of their high school was online. So what I noticed was a lot more explicit instruction was needed, which I wasn't necessarily used to. A lot of the time, kind of pre-pandemic, you got 30 people in a lab, you say, "Hey, here's a lab, let's get going." And they would just kind of take off. With the fall, I would do this because it had worked great in 2019. And they would get stuck on like, how do I log in? Well, oh, just click the login button. Okay. And like it was like little 30-second bugs where it used to be they would stop and raise their hand for help when it was like a major, like, let's sit down and really kind of dive into your code and debug it, which was not necessarily expected. Another thing I kind of noticed is that this is more of a hunch than necessarily like backed in research, I would imagine math instruction definitely took a hit through the pandemic. And with that, students came in with a little bit less of a foundation and like functions from a math perspective, where I found in 2018, 2019, a lot of my college kids kind of came in with, I generally know f of x equals something. And then when we apply it to computer science with like function programming, there's some kind of correlate that would click. I really had to challenge myself as an instructor to teach it fundamentally different and kind of break down what is a function, what is domain range, what is input output, and then also what is abstraction. And that kind of had made me redesign a lot of my different teaching methods. The other things I noticed was they needed a lot more encouragement for exploration. So a lot of the time they would hit a roadblock and kind of just stop and go, I can't do it, TA, please help. So what we had to do was a lot more kind of conversations of like, oh no, just try it. Like, what do you put that block there? Like a lot more of kind of like coaching with that. And also usually in 2018, 2019, college kids, you say, hey, pick a partner, look at left, just pick someone. It's half the work. They're of course going to pick a partner. We had to do some like a little bit of coaching of like, hey, you really should have partners for lab work, whatever. In the fall, I noticed much more college students would be rather work alone. And this is going to kind of permeate some of the other findings with the high school students, and then we'll go on to the teachers. But this is kind of like the center that we're going to kind of expand from. The next group I want to talk about is my high school students at the BGC Summer Academy. I talked to the other instructors that taught with me to kind of just solicit some feedback on what were some observations they've had, because they've all taught the college students as well. And what this program was, it was this awesome 2-week program where students lived on campus. They came from all around the country, with students from Brazil, Vancouver, the Bay Area and beyond. And they kind of came in with like little to no experience. We did have to separate some students that kind of skipped the first 2 weeks of the curriculum. So it was kind of like beginner or like more beginner, I guess, if you will. But most students came with little to minimal experience. And what happened here was I've taught middle school, I've taught college, but I haven't really done secondary like high school CS. So what I found was functions and build your own block and abstraction required a lot more explicit instruction. So a lot of the time students would, for the keynote, we saw like how you built a square. I would see students, instead of making a square function, they would just copy the square code into 7 places. And we would explain to them like how abstraction is this beautiful thing, and you can like make a block and use user input, and then they would do it, and then they would take in size as like a variable, and then not use it in their code. It would be like a set size to 100. So we had to do a lot more explicit like education of like, how do variables work? What is the purpose of abstraction? How does it make your life easier? You don't want to copy the square like 4 or 5 lines 7, 8 times in your geometry project, right? And the other thing that we noticed, which was fascinating and I've never seen before, is students worried a lot about user inputs rather than just assuming that the variable will be like a number. So with like any of the draw and tape activities in lab, a lot of the time they'll be like, oh, I don't know what the user is going to write. And I'm like, exactly, that's the beauty of abstraction. We should code it to like handle multiple inputs. But a lot of the time in the code, they would kind of get stuck on this, where they would be like, well, the user has to input something, right? Well, I'm like, well, if you're doing like temperature of Mount Everest, there's not really user input. You're going to pull from a database and calculate stuff. And like that idea took a lot of time to kind of sink in. And I talked to the other instructors about their opinions for this. And I found that their theory of this is that students may have been exposed to coding through Scratch and through games, where the emphasis is an input, right? If you're building a game in Scratch, you're not doing a whole lot of calculations. It's very much type this in and then do something with the user input. So kind of teaching students like sometimes that's not going to be the case was a big endeavor. The great part about high school students was, unlike the college students who would kind of just pause and be like, I need help, I'm kind of lost, high school students were much willing to kind of just go down the road and kind of figure out, like, build it as they were going. So they were much willing to tinker and to get unstuck. And a lot of the time this was great, where it would be like, wait, I'm kind of confused. And then they would try to move blocks around. They would try, instead of writing the word size, they would finally drag the variable size. And then all of a sudden their code would work, which was kind of cool to see kind of like the youthful energy of growth that like was not necessarily there once they get to college at Berkeley. But with the high school, our students, I think, were 15, 16, so kind of middle high school. And this was very interesting and kind of informative as I went on to my final part of this talk, which I think I'm most excited to talk about. At UC Berkeley, there's a teacher education program, where in the state of California, it's kind of interesting where you have to get your credential. You can't really get a CS credential. You have to get in something else, and then you get this thing called a CS authorization. And it's like this add-on. So the Berkeley School of Education offers this, which is really great. So students are in an MA of Education program, they get a teaching credential. A lot of my students started student teaching Monday. They start Monday, which is kind of exciting. And these students said, hey, on top of my social studies, science, math, kindergarten Spanish immersion, I want to do computer science as a kind of bonus. And the way it works is their first course in the program is block-based programming. And I actually want to thank Dan, because I originally was like, I'm busy this summer, I don't want to do this. And then Dan was like, you are the person to teach this class. And I'm like, okay, I guess. Best thing I've ever done. I had a bunch of my teachers here at SnapCon yesterday, so they were super excited to meet everyone and go to the workshops. And teaching teachers who were vast in difference. Some were science teachers, some were social studies. I have a student who's going to teach kindergarten Spanish immersion. How do you teach programming with this lens that it's going to be used in everything from kindergarten to AP chemistry? So these are some things that we kind of that we noticed happened. Teachers are under a lot of constraints, which means that when they get introduced to the word of computer programming, where it's all about tinkering, it's all about messing around and trying to build it as you go and learning through mistake making, there was a lot of clashes. A lot of my teachers kind of said like they're used to rigid lesson planning where it's like you have to write the standard, you know what I mean? A lot of their day-to-day life is a lot of rigidity. So when I'm like, do whatever you want, mess around, have fun with it, there was this clash of like kind of like how to think about it. So what I decided to do was one day during lab, everyone was kind of getting stuck at the same spot. And it was because they weren't willing to kind of tinker with the code. So I stopped class and said, y'all, you have never done computer science before. We need to think about it differently. And we did kind of a little workshop on growth mindset and how to tinker and how to like in chemistry, if you mess up your chemical formula and titration, you have to throw it out and start over. In computer science, if you put the wrong variable somewhere, 5 seconds later, you're back on the road, right? And you can kind of fix it in the moment, which in other disciplines isn't super common. So once we kind of went through that workshop, all of a sudden, light bulb moment. Teachers started to mess around. They started to go, wait, is it item I or is it the number, or is it the variable I? And they started to kind of communicate about changing. What also came up was teachers weren't really exposed to computational thinking in their programs. So that led to a lot more discussions about kind of how to think about CS versus the actual CS. And the other cool thing that really came up was they were fascinated by bringing CS into multiple lens, which makes sense. They were teaching computer science, social studies, math, English. So they wanted to explore CS in different lens. What if we wrote an essay about AI? How would you explain an automated car to a 4-year-old? You know what I mean? All these different discussions that like CS wasn't necessarily just coding, but this kind of broader field of thought. I'm running a little low on time, so I'll speed up a little bit. My main kind of summary is that teachers and college students probably require explicit coaching and instruction on tinkering and kind of CS practices of kind of messing around and kind of growth by exploration and kind of like constructivism almost. The other part was for teachers and also high school students, abstraction can be an increasingly complex art concept. So thinking about how we teach it and kind of almost metacognitively, like how do we think about thinking about abstraction is really powerful as we kind of introduce it to students who have never really thought this way before and grow computational thinking. The other thing that I noticed through my working with teachers is a lot of the teacher pathways to computer science, it's very much either take CS majors or STEM majors and make them CS teachers. Or let's take regular teachers and train them on our one curriculum, and they're going to get really good at that one curriculum, but overall computer science understanding may not be the best. So there's not a whole lot of research about how do you cultivate computational thinking with teachers to kind of get them in preparation to teach CS in multiple disciplines. And I think that really should be the future. If we're trying to accomplish CS for all, we're going to need to train all teachers to be able to do so. Thank you, and I'll take about 5 minutes of questions. Unless I'm over. Oh, no, I have 5 minutes.
No,
Perfect.
no, yeah, you have 5 minutes.
Well, I didn't see this as a question, but I have to agree with Dan. You are the man to do this. That was wonderful, Brendan. Really. Thank you.
Thank you.
Is that slide deck available to us?
I'll upload it to my workshop.
Thank you much.
And then I'll also, on my last slide, this is my email. This is going to be my dissertation work, is trying to build better, different computer science curriculums and philosophies of pedagogy kind of with it. So if you want collaborations, questions, consult, my inbox is always open as I kind of get further in my PhD program.
I just want to comment, it's a very nice research that you're doing. It's things that we've known since computers were introduced, that teachers, like children, like students, need opportunities to mess about, and that it's legitimate, but debugging is a great experience. Thank you.
Now I'm actually a third generation teacher. So I come from a family of teachers. So I love to kind of do as much as I can for that community.
Hey, Brendan, I really enjoyed your talk. Thank you so much. One question I do have, and this is something I was most excited about, was the interdisciplinary approach you're taking with teachers that are not necessarily computer science teachers. And I mean, what was your experience so far in how they are really accepting that? Are they finding ways to integrate that? I mean, I know you touched on it, but do you find that they really think they can bring that into the classroom, or is it just something they're exploring?
Yeah, and that's a great question, and something I had to talk about kind of I only had 10 students, so I was able to individualize it very well. And pretty much what we talked about is CS doesn't always have to be a computer. You have your text program or your Snap open. So we talked about how could you do an unplugged activity in a first grade classroom that gets to some computational thought processes, and that CS can kind of take different forms. I took this from BJC to do social implications of computing. So we always started with like the news of what's going on. So I brought up like Ukraine is using a team of hackers to kind of fight back, which could be great in a social studies class, that could only work 5th grade to 12th grade. Talk about the history of conflict of the Soviet, so and then resources. That was a big thing. My teachers were like, we are hungry. So I have a website with pretty much just for, if you're 2nd grade, if you're Spanish, if you want this, and just as I find stuff, I post it.
Wow. Yeah, great work. Keep it up.
Thank you.
I'd like to make another comment. The title, Beauty and Joy of Computing, I think is a really good way of thinking about using computers as opposed to computer science. For the most part, I assume the teachers you're working with are not computer science AP teachers. They're using computers you want them to be using computers creatively. And anyway, names are important.
No, and I agree.
I find computer science off-putting.
One, I think a lot of the teachers did too. It's scary. It's a scary word almost, but like the beauty and joy of computing, that's a warm hug welcoming you into the field. So I love that approach.
Hey, Brendan, I'm gonna have to cut you off there. Thank you so much for the talk. It was very fascinating and interesting.